Hi guys, so in this video what we're going to do is going to look at solving index equations. That's essentially just equations which have indices in them. So for example, we might have 3 to the x is equal to 27. Now that basically means 3 to the power of something is equal to 27, and this one's actually quite trivial. It's not that difficult. You know, you could just sort of go through the natural numbers there. 3 to the 1 is 3, 3 squared is 3 times 3, which is 9, and 3 cubed is 3 times 3, which is 9, 9 times 3 is 27, and therefore x is equal to 3. It isn't a difficult one to solve, but obviously there are going to be cases when there aren't whole numbers and that we need to have a method in order to do this. And it's fairly straightforward. What we do here is we need to get the bases the same. So we need to have the base the same. And the base number is the big number. So you can see this is the base number of 3 just here. So I'm going to try and get this into base 3 if I can. So here you can see that 3 to the x, because the base is not going to change, is equal to, and we can write 27 as 3 to the cube. Now once we have the bases the same, that means that all we need to concentrate on is the index. And you can see here that the index here is x and the index here is 3. And because these bases are the same, that means that the indices or the indexes must be the same here. X must be equal to, or this left-hand side must be equal to the right-hand side. So we essentially just drop the bases. Okay, so drop the base, and we end up with x is equal to 3, because the bases are the same, so we don't have to worry about them. Now that's a nice, easy example. We'll have a look at something that's a bit more complicated now. So let's have a look at, for example, 8 to the power of x is equal to 16. Now, I said that we want them all to have the same base. So you can see here that 16 isn't going to work into base 8 here. So we need to start thinking, what can we use as a base here? And generally, guys, when it comes to the leaving cert, it's normally 2, 3, or 5. I'm going to be honest with you. All right, so if we have a look here, we can rewrite 8 as 2 cubed. So we've got 2 cubed. That's also to the power of x. And that's equal to, and on the other side here, 16 is 2 to the power of 4. Okay, so I've not changed the equation. It's exactly the same. It's just been rewritten so that we have the bases the same. Now, using my index laws, the left-hand side becomes 2 to the 3x. Remember that we multiply them. And that's now equal to 2 to the 4. And now we can see the bases are the same. So therefore, we can drop the bases, and we just end up with the indexes being equal to each other. So we get 3x is equal to 4, and x is equal to 4 over 3. And that's our answer. Now, suppose we have a fraction. Again, so let's have a look at a fraction here. So suppose we had 2 to the x, sorry, try that again. Apologies, let me write that. 2 to the x is equal to 1 over 8. So here's another question we might be asked. And what we're trying to do is we're trying to get that 1/8 to be written in the same base as the left-hand side. And obviously it's going to have to be base 2 here. Now, 2 to the x, that's not going to change, is equal to, well, 1 over. And we can say that's 2 cubed. But we still haven't got the right-hand side to be an index without a fraction. Now, again, one of our rules, our index rules, we should know them by now, is that we can change 1 over 2 cubed for 2 to the minus 3. And now you can see we have our base number the same, everything's on top, there's no fractions, so therefore we can drop the bases again, and we end up with x is equal to minus 3 in this case. So let's try something a little bit more complicated. So we have 8 to the 1 minus 2x here is equal to the square root of 1 over 32x, and we're asked to solve this particular index equation. So again, we have to come out with a number that we can write both the left-hand side and the right-hand side to the same base. I think we've sort of managed to realise that 8 is generally base 2, so it's 2 cubed by 1 minus 2x on the outside there. And that's equal to, and we'll just use the square root still, and we'll break it down slowly. 1 over, well, 32 is 2 to the power of 4 is 16, so 2 to the power of 5 there, and that's multiplied by x. Okay, so we can simplify the left-hand side and say that that's, remember, when we see two brackets next to each other, we multiply them out, so that's just 2 by, and you could just leave it 3 minus 6x, so that's the left-hand side all sorted. Okay, so that was just 3 by 1, 3 times minus 2x. And now the right-hand side is going to be a bit more tricky, but it should be okay. So what we have is we've got 1 divided by 2. Well, 5 times x is just 5x. But then we've got this square root, which is a bit of a problem here at the moment. And we know that we can rewrite the square root as an index of a half. So this is to the power of a half, all of it to the power of a half. Okay, so 2 to the 3 minus 6x, as I said, that's not going to change, is equal to 1 to the power of a half divided by 2 to the power of 5x to the power of a half. Okay, so the square root of 1 is just 1 anyway, so that's not going to make any difference. So, and 2 to the 3 minus 6x is equal to 1 over, and 5x times by a half, so that's 2 to the 5x over 2. Nearly done. We've got 2 to the 3 minus 6x on the left-hand side, but now we're going to have to make this negative because it's on the bottom, so it's 2 to the minus 5x over 2. And we now have on the left-hand side 2 to the power of something, so 2 to the power of something here is equal to 2 to the power of something on the right-hand side. So it's just the base, and we have an expression on the top is equal to base, an expression on the top here. That means that we can drop the bases, as we only need to equate this with this, and that means that we now have 3 minus 6x on the left-hand side is equal to minus 5x over 2 on the right-hand side. Now, it's up to you how you solve this. I'm going to multiply everything by 2, so if I multiply both sides by 2, I get 2, 3 minus 6x on this side is equal to minus 5x on that side. And that means I get 6 minus 12x is equal to minus 5x. I'm then going to get all of the x's onto one side. So I'm going to take the x's from the left-hand side to the right-hand side. I get 6 is equal to minus 5x plus 12x, which is 7x. And therefore x is equal to 6 over 7, and we are finished.